Hello there. We're going to do mole questions today. So we are given the density and we are given the liters, and octane is the normal gas that we pump to the car. That's the molar mass we can calculate. 8 times of carbon is 12, 8 times 12 plus 18 times 1 for the hydrogen. So that's come together 114.23 grams per mole. So the molar mass has to be kept separately calculated because it's better, it's a simpler one. Okay, now, so the density can be written in two ways. Remember this way, just think about that, write it by the side, zero point 0.7 over 1 mil or 1 milliliter over zero point 0.7 grams. They both actually correct, right? It's not the traditional density writing, but this is how we want to write for the mole calculation. Again, think about the question, moles we are looking for, and we are given, the givens are two of them. One is 1 liter single unit. Start with the single unit 1 liter, not the density one, because density one has two things, two forms, right? Now we also have, we figured out the molar mass, which is the grams over mole. This definitely mole should be on the top, right? Because we want to end up with the moles, right? Now we have grams and we need to have the connection. We need to cancel this gram. So we're going to put the gram, zero point 0.7 gram on the top and milliliter in the bottom, so we can cancel gram to gram. See the red light, red signs, gram to gram canceling. That's the key point. Okay, now we have a gap, mill and 1000 milliliter and 1 liter. You plug it in to cancel the mills. So and the liter to liter cancels out, right? Now, once you have the right unit, which is moles left over, take all the numbers on the top of the line, which is all multiplication, and below the line all division, plug into the calculator. The one bracket on the top, one bracket in the bottom is enough. Now you will get 6.13 moles. So that's the answer for that one. Okay, let's look at this question. So we are given, let's see, molecules are given. Actually, the question asking is mills. So I want to end up with the mills and I want to start with the molecules. So let's see, molecules to the mill. How do we go that? So we need the mole bridge, which is the Avogadro. One mole is 6.02 10 to the 23 molecules, right? We may need STP, one mole is 22.4 liter. That could be two forms, we will see, right? Now we know moles on the top here, so therefore we need to have 22.4 liter divided by 1 mole. And then liter, milliliter, we need to put it the suitable way. So let's get started here. So what is given? 6.10 to the 20 molecules, and we need the Avogadro 6.02 10 to the 23 molecule over 1 mole. Cancel the molecule to molecule. 1 mole is 22.4 liter, and then 1 liter is 1000 mil. So let's cancel molecule to molecule, mole to mole, liter to liter. You left with milliliter. That's the whole point, right? So you get the right milliliter units. Multiply everything on the top, but this case you have power. Let's use a good calculator. So this is Desmos, or you should use the TI-84 type. See my brackets. The brackets are really important for the powers, otherwise you will get wrong answers. So the bracketed power, then 22.4 liter times 1000, then divided by the Avogadro, which is 6.02 10 to the 23, bracket again. So those are the key points. So now it'll give you the answer. So that's what you want to do, right? The brackets, brackets, brackets. That's the important thing. Okay. Now, so yeah, so you end up with the 22.32 milliliters. So that's the answer for that one, right? Let's look at this question. So propane, C3H8 given, and then my question is liters. We want to end up with liters, right? Okay, so 9.5 kilograms, right? And then 1 kilogram is 1000 gram. We know that, we have to know that, right? And so now kilogram to kilogram canceled out, you get end up with the grams, right? Now also we know liter business comes with the 22.4 liters. So we can write it in two different ways. So let's get the molar mass for propane. See, 12 times 3 and 8 times 1, that's 44.1 gram. Plug in here, and that's the molar mass, right? So let's go back and get started here. So 9.5 kilogram, cancel the gram, 1 kilogram is 1000 gram, and the molar mass for the grams, cancel the gram to gram of the molar mass and the grams, and then the mole to mole cancels out. So you left with the liters. So let's calculate again. So this one is easy. So that all the top over the line everything you multiply, or below the line everything you divide, or you just need one bracket for the top, one bracket for the bottom, right? So you get 4825. That's it, right? So let's go to this question. How many moles of air are exchanged in a normal breathing with a 2.2 liter lung capacity? So that's a normal lung breathing, right? So our question is oxygen, and we are given the 2.2 liter. So we know 1 mole is 22.4 liter. We'll go there, but the question actually should be oxygen. Okay, oxygen is 20%. So the 20% don't have a unit, don't need to have a unit. So that means 2.2 liter, you need only 20% to consider oxygen. That's why 20% goes 20 over 100. Then you plug in the 1 mole over 22.4 liter, right? So see, the liter to liter cancels out. The percentile don't have a unit. You left with moles of oxygen, right? Easy calculation. Everything above the line you multiply, everything below the line you divide. That's it. So you end up with 1.96 scientific notation here. So you jump 2 to the right,